Okay, so here in example 3, we're adding and subtracting rational expressions, and we're going to use trinomials. In the first term, I have 4 over 3x squared plus 10x plus 3. In the second term, I'm adding 2 over 3x squared minus 2x minus 1. Notice my denominators are both trinomials, and we need to factor those using factoring techniques. My leading coefficient for my leading term of x squared is not 1, it's actually 3. So we're going to have to use more advanced factoring techniques. So I'm going to have to find numbers that multiply to give me 3 times 3, which is 9, but add to give me 10 on the first one. In the second one, I need to multiply 3 times negative 1, which is negative 3. So I need to find numbers that multiply to give me negative 3, but add to give me negative 2. So in the next step, I'm going to rewrite this. I'm going to have 4 over. Now the numbers that multiply to give me 3 but add to give me 10 are 9 times 1 and 9 plus 1. 9 times 1 is going to be 9, and 9 plus 1 is going to be 10. So we need to separate 10 into 9x and 1x. So we're going to say 3x squared plus 9x plus 1x, that's just a singular x, plus 3, plus 2 over, and again, we need numbers that multiply to give negative 3, but add to give negative 2. Well, that would be negative 3 and positive 1. So we're going to say 3x squared minus 3x, there's the negative 3, plus 1x minus 1. So remember, the negative 3 and the 1 multiply to give me negative 3, but add to give me this negative 2. Okay, so now we're going to group these two and these two, and we're also going to group these two, and we're going to factor them. So the first step, we're just going to rewrite the 4. No need to change anything yet. We're just rewriting. And here in the first part of the group, we can factor out a 3x. So we're going to factor out 3x, open a parentheses, and that's going to leave us with an x plus 3. In the second part, there's really nothing to factor, so we're going to factor out a 1, and again, that leaves us with x plus 3. Plus 2 over, and again, we look at the first group here, and it looks like we can factor out a 3x. So we're going to factor out 3x, and that leaves us with x minus 1. In the second group, there's nothing to factor, so we're going to factor out a 1, and that's going to leave us with x minus 1. So now we go ahead and finish factoring. So notice I have a common factor of x plus 3 here. So that means I'm going to have 4 over x plus 3 times the remaining factor is 3x plus 1. So we're going to put 3x plus 1 right here. Plus 2 over, and in the second term we have a common factor of x minus 1. So we're going to write x minus 1, and then we have a remaining factor of 3x plus 1. So 3x plus 1. So now we fully factored our two rational expressions. And notice there's a common factor in the denominator of 3x plus 1. So we don't need to multiply 3x plus 1 when we're finding common denominators. But in this first rational expression, we have x plus 3 and 3x plus 1. It looks like we're missing a factor of x minus 1. So in the first fraction, in the first rational expression, we're going to multiply x minus 1 in the numerator and in the denominator. In the second rational expression, in the second term, we have x minus 1 and 3x plus 1 as our factors, and it looks like we're missing this x plus 3 as part of our common denominator. So we're going to multiply x plus 3 in the numerator and in the denominator in the second fraction. So let's go ahead and do that. So in the first term, we're going to have 4 over x plus 3 times 3x plus 1. And then we're going to multiply that by x minus 1 over x minus 1 plus 2 over x minus 1 times 3x plus 1. And we're going to multiply this by x plus 3 in the numerator and in the denominator. And now we're going to multiply across. So 4 times x minus 1, well, that's going to be 4x minus 4. And now in my denominator, I have x plus 3 times 3x plus 1 times x minus 1. Plus, and now if we multiply in the numerator across in the second term, 2 times x plus 3 is going to be 2x plus 6. Now in the denominator, let's put these in the same order as before. We have an x plus 3, so we're going to put x plus 3 just so this is nice and organized and in order. Next we have 3x plus 1, which is right here, so we're going to write 3x plus 1. And then our last factor of x minus 1 is at the end. So now notice we have common denominators. We have the same denominator for both of these rational expressions. So we can just combine the numerators. So in the next step, we're just going to combine everything. We're going to say 4x minus 4 plus parentheses 2x plus 6. And all of that is going to be over x plus 3 times 3x plus 1 times x minus 1, that common denominator that we had. And now we can combine like terms. Since this is a plus sign and not a minus sign, I don't need to distribute it to the parentheses, so I don't really need these parentheses. So I'm going to go ahead and remove them. I just put them at first just so it's organized because I know this is another group right here, so I just wanted to keep it nice and organized. But because this is a plus sign, we don't need to distribute a negative, so we can just go ahead and write the numbers as is. And now we're going to combine like terms. We're going to combine 4x with 2x, which is going to be 6x. Negative 4 and positive 6 is going to be positive 2. And all of that is over x plus 3 times 3x plus 1 times x minus 1, okay? And now we check, can we reduce, can we simplify? Well, in the numerator, 6x plus 2, that can be factored. I can factor out a 2. So we're going to say 2, open parentheses, and that's going to leave me with a 3x plus 1. And then our denominator is still x plus 3 times 3x plus 1 times x minus 1. Well, I can reduce the x plus 1. So that leaves me with 2 over x plus 3 times x minus 1. And that is about as far as we can go. There is my sum. And that is example 3. Now this was a pretty long problem, so this is about as far as I'm going to go in this video. In the next video, I'm going to show you an example with complex fractions.